My name is Emily Preuss, and my project is rapid online steroid extraction from dried blood spots for anti-doping analysis using online supercritical fluid extraction, supercritical fluid chromatography, mass spectrometry. Anti-doping policies and regulations among sports organizations and governments are of ongoing importance. The current methods of analysis have significant challenges due to excessive time required for method validation and extensive sample preparation. So we want a more rapid technique to detect the abuse of these substances using online SFE-SFC-MS. There's a debate on blood versus urine. Even though blood has a biofingerprint of doping and urine doesn't, urine is preferred because blood is considered invasive and has international guidelines, so the availability is limited. We are using 23 steroids in the category S1 of the WADA list of restricted compounds. Here are 3 of the compounds we are looking at. For sample prep, the standard blood spot collection takes a 1.2 millimeter core from a large blood spot, but the components of the blood do not spread evenly. As you can see in this dried blood spot, there's a ring around the edge. So this core does not represent the entire spot. We decided to do a micro DBS collection where we have only 5 microliters of blood and use a standard hole punch with a diameter of 6 millimeters to collect the cores. With this technique, the cores represent the entire contents of the blood spot, and we are able to fit all of the types of spots on a single card, as you can see in this picture. The samples were applied to Whatman preservation cards, and we used bovine and human male and female blood. We spiked the blood with our anabolic androgenic steroid mix of the 23 compounds at a 1:5 ratio. So for overall sample prep, we applied the samples with a pipette, let it dry for 3 hours, punch out the spot, and then put the spot into a 0.2 milliliter vessel. We used the Shimadzu Nexera UC system, and this is a representation of the instrument setup for online extraction, but the SFE can be taken out for just SFC-MS analysis only. This is the extraction process, and these figures show the flow path and the extraction loop. We started with an SFC method for chromatographic separation of the 5 critical groups where the MRMs overlap. These were the parameters we were looking at, and this is the optimized SFC-MS method. And then this is the chromatogram where we did a 1 microliter injection of our AAS mix. Below are the chromatograms showing the separation of the critical groups. For the online SFE-SFC-MS method, these are the parameters we were looking at, and here's the optimized extraction method and the chromatogram using a 1 microliter spot of AAS mix and showing the duration of each step. Here we compared the spot with AAS mix with blank and spiked bovine blood spots. We were able to extract all compounds from the spiked blood, but at lower intensity. And then for the blank blood, there were low levels of 3 steroids. We then compared an AAS mix spot and spiked bovine spot by doing 3 rounds of extraction on each vessel. These graphs show the percent extracted from each round from the total extracted for each compound. For the AAS mix, 70% was extracted in the first 2 rounds, but most compounds require more rounds for the spiked bovine. The spots were quantitatively cored and analyzed by online extraction, analysis, and detection of the 23 compounds in under 30 minutes. Peak areas were reproducible, and even though there were increased background signals for both the paper and blood, there were no interfering signals. The matrix effect of the bovine blood caused some peak areas to be lower and require more extraction rounds. We are working on method validation using the human blood. I would like to acknowledge the Shug Group, Shimadzu, and ResTech. Thank you.